Hello everyone, and thank you for joining my session. Here, we'll dive into the dynamic world of Kubernetes and explore how to create different Kubernetes objects using the Go programming language, of course. Before we dive into the code, let's take a quick look at our agenda. Here we have the client to Go, Kubernetes API and API machinery libraries, how to connect to our cluster from our Go application, of course, managing resources, controllers and operators, operator hub, and then wrapping our session up. I'll do my best to cover each of these topics, providing as much information as possible within our limited time together. So, to the next slide. What are client to Go, Kubernetes API, and API machinery? So kubectl is the official client to the official Kubernetes client to interact with Kubernetes API. But we can use client to Go, Kubernetes API, and API machinery to interact with Kubernetes API server as well. But what are they? So the client to Go library is like the primary part or the primary library to interact with Kubernetes. It provides various tools to create, modify, and delete Kubernetes objects. Kubernetes API, when we use client to Go library to interact with these resources, we actually modifying the Kubernetes objects defined in Kubernetes API. So basically, Kubernetes API is where we define our Kubernetes objects. Lastly, we have the API machinery. API machinery is like a collection of utilities used to help us interact with Kubernetes API better. Stuff like selectors, meta, scheme, and so on. So now let's dive into our code and check how it's done. Now that we have established what are these packages and how they interact with each other, let's see how it works. Here I've created an empty directory, and the first thing we need to do is to initialize our Go module. So Go mod init Conf42 Kubernetes with Go. Then we want to get our core libraries, which are the client to Go, API machinery, and API library. Kubernetes.io, client Go, then API machinery. Then we want to create our main.go file. And here we're gonna create our package main, then func main. Within our func main, we won't get our kubeconfig equals file path join home dir from client to Go utils, then the file name. So I'm assuming I'm assuming your kubeconfig lies under .kube folder, so you can change the path if you need to. By the way, if you don't have a cluster running, you can always use Kind, which is an amazing tool to create your cluster in your machine using Docker. So it will create a cluster for you. Then what we need to do is to create a client set. First, we're gonna create a REST config to pass to the client client command. So REST config and error equals client command build config from a flag. Then we want to empty string, then the kubeconfig file. If error equals nil, we're gonna panic here. Then we want to create our client set using a Kubernetes interface. So we want to import this interface, client Go, and we can use this interface, Kubernetes, new for config. Then we're gonna pass the rest config. Of course, here we're gonna have the client set and error doesn't equal nil. We're gonna panic. Then voila, we have our client set here. Of course, there is a million way to uh, get the client set or to communicate with Kubernetes, but this is the way I'm most comfortable with. Now we want to check if this client set is working as expected. So we will get the number of nodes or the nodes we have in our cluster. For example, we have a kubectl get. Here I have a single node with this name. We want to do the same thing here. So list an error equal client core v1 nodes list context background list options from apimachinery. So we're gonna rename this v1 because there is multiple interfaces with the name v1. So we're gonna name this one meta v1 and use it here. Then we want to iterate over this list, range list items. Then we want to print the name of our nodes. So record name. Let's check it out. Go run main.go. Okay, go mod. Go run main.go. And here we are. We have our node with the same name. So that's it. That's how we connect to Kubernetes using a client set. Of course, you can take this further and create a singleton for your client set, so you don't need to initialize it every time. But I'm sure you can handle this. For the sake of this example, we're gonna make it simple and easy. Now we want to create a pod using the core v1 interface from API library. We can create our pod. So basically what we need to do is to create the pod struct. It takes a pointer to core v1. We need to create the core v1. So core v1 is from Kubernetes API core v1. We're gonna specify the pod detail. We're gonna define the object meta. It's from meta v1 object meta. Here we're creating a pod named, let's say, demo pod. Then we want to define our containers in this pod. So spec core v1 pod spec will define the container. Container gonna be core v1 containers. We'll define a single container. We'll define a single container named nginx. Now we using the client set, we're gonna create a pod client. So a pod client gonna be client core v1 pods within the default namespace. Using this pod client, we can create, update, or delete our pods. So pod client create, we're gonna pass the context background, gonna pass the pod, then we gonna pass the list options, the create options, sorry. This will return a pod and an error. So result will check if we got any errors. Don't equal nil, we're gonna panic. Then we want to print out the pod name. So, and here we go. Let's run this. Go run main.go. As you can see here, we have the node name and the pod. If we checked using kubectl get pods, we'll find here we have a pod called the demo pod, and it's up and running. That's it for the pods. So next thing we want to do is to create a deployment. Similar to creating a pod, let's start and define our deployment. Create deployment. But first, let's import the apps v1 package. Apps v1, Kubernetes API, apps v1. And here we can create our deployment struct, apps, and we'll name our deployment meta v1 object meta with the name deployment. Then we want to define our spec, apps v1 deployment spec. We'll define the replicas. We're gonna have two replicas. It needs a pointer to integers, so here we're gonna say, for example, and int 32 with the number of deployments, and here we're gonna pass pointer to the number of replicas. Then we want to pass our selector from pointer to meta v1 label selector, and here we're gonna match labels. We'll have app and demo, for example. Then what we want to do is to define our template. So after the spec, we want to have the template similar to the YAML file. If you used kubectl with the YAML files to deploy a deployment, it's similarly, it's the same thing here. So the spec gonna be, the template gonna be here, template core v1 template. The trick here is to know which interface to use with which. So with the spec, we're using apps v1. With the object meta, we're using meta v1. Here with the template, we use core v1. This is the trick in this part, but it's very straightforward, nice and easy, as you can see. So object meta, as you guessed, it's gonna be meta object meta with the name. No, we don't need name. We need labels here. Map string. Then within our template, we want to add our spec, pod spec, like containers, similar to our pod above here. We'll define a container as well. So let's say core v1. We're gonna have a single container with the name web, for example, and the image gonna be nginx. What else? I think that's it. This is our deployment struct. Now, similar to pod, we want to create our deployment client. So, a deployment client from the client set, of course. So deployment from our client apps v1 deployment within the default namespace. Then we want to create our deployment from the deployment client. So we're gonna say deploy and an error equals deployment client, create context background and our deployment, and meta v1 create options as well. We'll check if we got any error. We'll panic with the error. Then we want to print out our deployment. Print line deploy result. Let's check this together. But first, we need to delete this pod, or just comment this part for the deployment, for the pods, I'm sorry, because we already have the pod here. So if we run this again, it's gonna give us an error saying you already have a pod named demo pod. No, we want to go run. So we have here demo deployment. Let's check get deployments. We have here two kubectl get pods. As you can see here, we have our deployment, our pods here as well. So you can as well delete your deployment using the deployment client. For example, we can to do to do using deployment. Let's comment this later. Deployment client. That's it. Now we have created deployments. We created our pod. We have created our client set. We can create secret with the same idea. Um, Listener, watchers, all the Kubernetes objects you want to create, you can create from this client set. You just need to know which interface to use, which interface to define the name, which interface to use when defining the spec, and so on. If you want to create something like ingress routes, you can always use something like traffic. And that's it for our third part, which is managing resources. In this session, we have talked about Kubernetes resources and how to manage and interact with these Kubernetes resources from our Go applications. However, sometimes you might have a great idea or a need in your app, and these resources aren't enough for you. Fortunately, Kubernetes support CRDs or custom resource definition, which a way we can develop our own resource. Let's say we have a resource called the burger stand, and we want to develop this resource and use it in our cluster or any cluster really. So I've created these files here. The first one is a burger stand, a CRD. The second one is the big bun burger stand, which is the resource I want to create at the end. So I want to let's try it out and create the resource without defining our CRD. So kubectl apply dash if. It will give us an error saying that Kubernetes service doesn't recognize this kind or this definition. So what we need to do is to create our CRD. Here we have the name of our CRD. We have the version here. We have the scheme here. The types is the properties of our CRD, like our resource, like location, capacity, is it open or not, scope should be namespace, the names like burger stand, and the kind of course, and short name to get our resource, similar to kubectl get namespace or kubectl get ns, for example. So what we want to do is to kubectl burger stand. Now we have our CRD configured. So let's try our resource again. And here we go. We have our resource created in our cluster. Let's check it out. kubectl get bs. And here we go. We have our resource. We can kubectl, of course, get bs big bun dash o yaml. And as you can see here, we have all the part of our resource. What we want to do next is to create a custom controller, because custom resource only won't give us the operator or the complete cycle of a resource. So the custom controller give us or expose an API which we use to interact with this resource, or save the desired state of this resource. I'll leave this part for you. You can look into it. A hint: you can use a Kube Builder. It's a great tool. You can use it to create your custom controller. After that, you would have your operator, which lead us to the final part of our session, which is Operator Hub. If we opened our browser, if I opened my browser, you will find into operator hub.io. You will find many operators here. Some of them like search manager, eager operator, which we use all the time with Golang application to trace our requests, and so on. So that's it. With that being said, I hope you enjoyed the session, and thank you for watching me to the end. And bye bye.